In this video, we're going to be looking at trying to find a polynomial when we're given any type of roots. So in our first example, we need to be able to write a polynomial looking at a graph. So the first thing we need to do is identify our zeros. We have 2, 0, -1, and -3. So if I were to write these out just as zeros, I need to make sure I write them as a factor, which will be x minus 2 for the first one. And then, having x equals 0 will be just x. X equals -1. The factor will be x plus 1. And then lastly, x equals -3, so our factor will be x plus 3. So remember, it's going to be the opposite for factors. So what we do is we take that information and we will end up multiplying it all out. So just setting it up with all our factors. Multiply all of this out, and when we do, we're going to get a final result as x to the 4th plus 2x to the 3rd minus 5x squared minus 6x. Okay, so again, all you have to do is identify your factors, your zeros, write them as factors, and then multiply them all out, and then you have your final answer. You have your polynomial. So looking at our second example, this is a little different. If you notice, based off characteristics we've been talking about with polynomials, this is an even degree polynomial. It actually has a degree of 4 because based off our terms. So if I were to, make out my terms, I have 1, 2, 3, 4. I have 4 terms, so that means my degree of this polynomial must be a 4. But if you look at our graph, we only see 1, 2, 3 roots. So this is an example where we have a multiplicity. And the multiplicity will be right here at -2. And the reason why is because our graph, does touch here at -2, but it does not go past -2. It touches and it comes back up. But you see here at 0, it goes through 0, and then of course it comes back and it goes through 2. So that's how we know there's only a multiplicity of 1 for 0 and for 2. So by writing this out, we will have x plus 2 squared. Again, we had a root at -2. Again, the multiplicity of that will be 2 based off, with our graph. So we have x plus 2 squared is our factor. We have x equals 0. And when we have x equals 0, we just have x as a factor. And then again, lastly, we have x equals +2. So that was going to be x minus 2 as a factor. So when I multiply all this out, writing it all out so I can get ready to multiply. And don't forget that when we have a power of 2, that means we actually have 2x plus 2, so we have to expand and multiply. But when we multiply all of this out, we're going to have x to the 4th plus 2x to the 3rd minus 4x squared minus 8x. And so now you see that I have a polynomial with a degree of 4. So the even degree at that. This chart right here does a very good job explaining multiplicities with the graphs. So looking at the first one, the graph does pass through. So when you see it, when a graph goes completely through the x-axis, then we know we have a multiplicity of 1 in that case for both even and odd. If we go to the next one, more of a squiggle, this polynomial is an odd degree polynomial, but our roots here could have a 3 or 5 depending on what's happening with the polynomial multiplicity. So again, this example is x minus 1 to the 3rd, so that means the multiplicity is 3 here. The next one is an even degree. It's kind of like that one we just saw, but it bounces, it just touches right here when it goes back up. So this is going to be an even degree polynomial, but we have multiplicity of 2 because there's 2 things that are kind of going on right here. Okay, and so, but since it is a 0, we just have x squared. And then lastly, we have, if it's more like a flatten out, kind of a bounce too. So it flattens and it bounces out. We're going to have, obviously if it was just a bounce, we're going to have, or touch, we're going to have 2 multiplicities. But here we could have, 4 or 6, depending on that. But at least it'll kind of give you an idea that there is multiplicities are happening in these places as you look at your graphs. Okay, the third example, now we're not even looking at graphs. I'm telling you what the roots are going to be. Okay, so if you're looking at this right here, the roots, we see 3 roots. We see 2, -2, and -6i. But remember, when we have, imaginary number, we also have its conjugate, which is +6i. So really, we have a total of 4 roots, okay? And again, that's including that conjugate. So you have to understand that even though it's giving you one, imaginary number, -6i, you have to understand that the other one is being applied there. So don't forget about it. So as I'm writing these out, I have x minus 2 to represent +2, x plus 2, okay, to represent -2, and then right here this will be x +6i, again to represent this one, and this last one will be x minus 6i. Okay, so taking that information, we would multiply it out. So if I were to multiply this out, I'm going to get x squared minus 4. If I were to multiply this out, I'm going to get x squared plus 36. So taking those two, we need to multiply them together and, distribute, and we're going to get x to the 4th plus 32, x squared minus 144 equal to 0, because since we did have the solutions, the zeros, the roots, that sort of thing, it is a polynomial, so that means we need to put x to 0 because it is an equation, and equations are used to help find the zeros of a polynomial. So our last example, we're given the roots 4 and 2 plus 3i. Now again, don't forget that since this is a complex number, we also have its conjugate, so we have 2 minus 3i. So really, this degree of this polynomial is x to the 3rd. Okay, so what we need to do is multiply this out. But before we multiply it out, we need to write our factors. So when we have x, so basically it's saying x equals 4. Okay, that's a 0. But we need to know its factor, which would be x minus 4. Okay, so for 2 plus 3i, we have x equals 2 plus 3i. But really, the factor is going to be x minus 2 plus 3i. Okay, and then the other one will be x equals 2 minus 3i. So that means it's going to be x minus 2 minus 3i. Okay, and so we're going to multiply it out. And the reason why it's going to be minus here is because if we look at, we're basically reversing this. Okay, so we're basically taking this term together and bringing it over to back to the other side where it would have been before we solved and set it equal to 0. So that, again, would mean you have to subtract that piece to the other side. Now, if you do, it's going to say, again, x minus parentheses 2 plus 3i, which is, if I were to distribute that subtraction sign, it would become x minus 2 minus 3i. But this piece right here is this. Even though I wrote this, it's still going to be the same as this. So same thing here. It's going to be x minus parentheses 2 minus 3i. Okay, and so if I were to distribute that negative, it's going to say x minus 2 plus 3i, which again is the same thing as here. So I just didn't necessarily show you all of this because all you have to know is that, the factor 2 minus 3i, 2 plus 3i, you're reversing it, and so it's going to be subtracting to bring it back to the other side of the equation. Okay, and so anyway, so from there we're going to multiply it all out. The rest of it I'll show you on the next slide of how it's being multiplied out. So here we are, we have our 3 factors, x minus 4, x minus 2 minus 3i, and x minus 2 plus 3i. The first thing I'm going to do is actually multiply these two together. It will make things a lot easier, and of course a lot easier on you. So I'm going to actually make a box. Again, this is your own suggestion how you want to multiply it out. I'm just going to use a box because it kind of makes everything a little bit more organized. So I have everything when I write this out, I want to have x minus 2 minus 3i here, and then x minus 2 plus 3i. So multiply across, so that's going to be x squared. It's going to be negative 2x. It's going to be negative 3ix, negative 2x, positive 4, positive 6i. This is going to be positive 3ix, negative 6i, and then it's going to be negative 9i squared. So I would then go through and combine my like terms. These are like terms, but I first have x squared. It's going to be negative 4x. If you notice here and here, those cancel. So I'm left with 4. And then, of course, you see here, these cancel as well. And then I'm left with negative 9i squared. But don't forget, I squared equals negative 1. So really, it's going to be positive 9. So this polynomial simplifies to be x squared minus 4x plus 13. So I'm going to take now this x squared minus 4x plus 13 and multiply it by x minus 4. Okay, so a whole lot easier by, canceling out your i's. So when I multiply all that out, I'm going to get my result to be x to the third minus 8x squared plus 29x minus 52 equal to 0.